Today we're going to talk about quadratic translations, and so what we mean by that is today we're only talking about moving the parent function up and down or left and right, and then in this last example we're going to do a little bit of both, up, down, and left and right. And so we're not stretching, we're not shrinking, anything like that yet. That's going to be the next video. So here's our parent function in its original form. This is also called vertex form. We have a times b times x minus h, all of that quantity being squared, and then plus k. What we're going to focus on today is we're just going to focus on the h and the k. So notice how the number out in front of x squared, or the number out in front of the parentheses, is technically a 1. And also notice the number attached to the variable x inside the parentheses is also a 1. So here a and b are going to be 1, and we're only dealing with h and k. Notice part of the formula though, it's the opposite of h, and so we gotta keep that in mind. So we're gonna start with the easier one, the k. The k is your function outside of the parentheses, and so we'll notice that it's not inside the parentheses and it's separated by a plus or a minus. So because it says plus 2, this means we're gonna go up 2, or a distance of 2, meaning every point from the parent function is gonna go up 2. Now our parent function, meaning y equals x squared, we're going to have 5 points that we need to know. We need to know that the parent function, y equals x squared, crosses the origin, or the y-intercept, or the x-intercept, is at the origin at 0, 0. We also have 1, comma 1, because 1 squared is 1. 2, comma 4, because 2 squared is 4. And in the same way, it's symmetric about the y-axis, meaning if I folded it over the y-axis, the parent function would land on top of itself, because negative 1 squared, a negative times negative would be a positive 1. Negative 2 squared would be a positive 4. So I do want you to know these 5 points. When x is negative 2, negative 1, 0, 1, and 2, we're going to get a y value of a positive 4 because we're squaring it, a positive 1, 0, 1, and 4. Now, when we talk about transformations, we're saying from the parent function, what is this new graph going to do? Well, this new graph is going to take that as if it's taking it off the board, and we're going to shift that up 2 units, or a distance of 2 for every single point, and then slap it right back on the board. So it's like taking every single one of these points, and instead of saying, hey, this is negative 2, comma 4, oh, well, this is actually just going to be negative 2, comma 6. It's going to go up 2 distance of 2. Instead of negative 1, 1, we're going to go up a distance of 2 to negative 1, 3. Instead of 0, 0, it's going to be 0, 2. Instead of 1, 1, it's going to be 1, 3. And instead of 2, 4, it'll be 2, 6. So now, if you look, the shape of the graph didn't change if we would have drawn this perfectly, but it's as if I lifted this off the board and shifted it up a distance of 2, every single point. What's interesting about this is it's really the exact same as absolute value transformations that we did toward the beginning of the year. However, what makes this a little more challenging is when we get to the vertical and horizontal stretches and shrinks. But at least now we can hopefully see that from my original, this new graph has shifted up a distance of 2 units. Now, in number 2, we don't have a vertical shift. We don't have anything on the outside of the parentheses separated by a plus or minus. So there is no k in this case. But we do have an h. Now notice again, the formula is opposite of that h. So we would normally say, oh, hey, this is a positive 3. Therefore, h is 3. But what we need to think about is this opposite. What does this opposite mean? Okay, well, really the opposite of this positive 3 is going to be a negative 3. And that tells me, hey, this is going to shift left 3. And that's going to throw you off because we look at this and see x plus 3. Oh, this is easy. It's going to go right 3. But because of the formula, this opposite of h, we have to remember to shift left because of the opposite sign. So opposite of this positive 3 is negative 3. So I'm going to shift left 3. So same thing, I'm going to move every single point to the left 3. Now, what I would like you to do in class is really focus on our vertex. Our vertex is this point at which the graph is changing directions. And so here, that's 0, 0. Let's shift the vertex left 3. So 1, 2, 3. And technically, you would shift everything else left 3, but it would maintain that same pattern like this. and we would have our U-shaped graph. So it's as if we took the parent function in the black and we lifted this off the board and we shifted it left 3 and slapped that right back onto the board. So inside the parentheses, because of the formula, think opposite of this direction. So I would look at that and think, oh, positive 3, I'm going to the right 3. But because of the formula, I need to go the opposite of positive 3. So that would be negative 3, so that means left 3. So remember the opposite, and that's only for h. It's only for inside that function. Now, what happens if we have multiple movements or translations? So what if we go up, down, and left or right? So we need to know what these are saying. So the easiest one is k. So this minus 4 on the outside means down 4. So we're going to go down 4. Opposite of this negative 2 is a positive 2. So that positive 2 means we're going to go right 2. So we're going to go to the right a distance of 2. And we're going to do that with every point. So again, just kind of start with the vertex. So our vertex is at 0, 0. We're going to go down 4, right 2. So I'm going to take that and go down 4, right 2, and here's my new vertex. And then from there, I would draw my U-shaped graph. And so I should look like this. Well, I missed. We get the idea. There we go. Nailed it. So again, if you get the vertex right, that is going to be the most important part on this. But again, it's as if I took this parent function and I lifted it off the board and I went to the right 2 and down 4 or down 4, right 2. That order doesn't matter. It would land right where the orange graph landed. Now in the next video, we're going to talk about how to stretch and shrink this vertically and horizontally. And that will be a little bit of a challenge. Also, remember, you can plug this into your graphing calculator. If you go to y equals, plug it in just as you see it with parentheses being squared, everything like that, and you can get an idea, is your picture matching what you did on your paper in Alex? So you can use your graphing calculator to help double check you, but it's actually faster to memorize these rules than it would be to go and plug it in to your calculator.